So, what if everything we thought we knew about the start of the universe is wrong? Some scientists who've even won Nobel Prizes are now looking at info that says our ideas about the cosmos might be way off. This all started because of some crazy new stuff from NASA's James Webb Space Telescope, JWST, a super expensive telescope that was sent up to see what the early universe was like. Almost right away, it started sending back pictures that shocked everyone. The universe was acting in ways that just didn't make sense based on what we thought we knew. Just a few months into its mission, the JWST baffled scientists with things they weren't expecting. It found galaxies that were huge, bright, and old that shouldn't have been there so early in the universe's history, going by our current ideas. We thought these kinds of things took billions of years to form, but the JWST was seeing them only a few 100 million years after the Big Bang. One of the big names who's talking about this is Adam Riess, a Nobel Prize winner whose work helped us figure out that the universe is getting bigger faster. He says that we might have really misunderstood the cosmos. The stuff the JWST saw when it looked at the cosmic dawn, when the first galaxies were forming, is making scientists rethink things they've believed for decades. The telescope saw star-filled galaxies that were already fully formed just 300 million years after the Big Bang, which is way too early for that kind of complexity. One crazy example is a galaxy called JWST 140. We're seeing it as it was only about 290 million years after the universe began. It's not some tiny thing either. It's over 1,600 light-years across and is making stars like crazy. One scientist said it's amazing that a galaxy that big could show up so soon after the universe got started. And it's not just one weird thing. The JWST has found a bunch of galaxies from that time, and they're all breaking the rules. They're too old, with structures that should have taken billions of years to form. They're too bright, shining with the light of billions of stars that shouldn't be there yet. And they're too put together, not messy like we thought they'd be. They've got shapes like disks and even bars in the middle, which you usually only see in older galaxies. Half to 80% of these early galaxies are long and flat, more like surfboards than the round blobs we were expecting. It's like finding dolphins when you were only looking for tiny bugs. These discoveries have not only surprised scientists, but also questioned the standard model of cosmology, the lambda cold dark matter, lambda CDM, model. This idea says that stuff in the universe forms slowly, starting with small clumps of matter that slowly join together to make galaxies over billions of years. But the JWST's findings show that the young universe was already full of big, complex galaxies. Alison Kirkpater, an astronomer at the University of Kansas, put it simply, everything is just too big, too soon. The difference between what we thought would happen and what we're actually seeing is so big that it's keeping some scientists up at night, wondering if their basic ideas might be wrong. This isn't just a small mistake. These findings are pushing scientists into what some are calling a crisis. The data has been checked over and over. It's real, and the instruments are working right. The Atlantic even said that the JWST's early findings made researchers wonder if their old models were wrong. Some people thought there might be problems with the telescope, but that's been ruled out. What's left is the fact that the young universe doesn't match what we thought we knew about how galaxies and stuff formed. Even the scientists who helped make these models are surprised. Dr. John Matherer, a Nobel Prize-winning physicist who helped design the JWST and measure the afterglow of the Big Bang, says that the galaxies the JWST is finding aren't what we thought they'd be. He says they're way bigger, brighter, and more common than expected. That's a big deal coming from someone who's right in the middle of Big Bang stuff and the JWST. Adam Riess, another Nobel laureate, used the JWST to try to figure out something called the Hubble tension, which is a difference in how fast we think the universe is getting bigger. But instead of fixing the problem, the JWST made it worse. Its super-accurate data showed that the local expansion rate is faster, which means that the earlier measurements weren't wrong. Riess says that we might be facing the fact that we just don't understand the physics of the universe. He's wondering if we really know what the universe is made of or how it works. And then there's Sir Roger Penrose, a Nobel Prize-winning mathematician who's known for his work on black holes. He thinks the JWST findings might support his own crazy idea, which says that our Big Bang was just one part of a never-ending series of universes. He thinks the old galaxies could be leftovers from a previous universe. It's a weird idea, but it shows how much these results are making even the smartest people rethink things. Even though everyone's shocked, a lot of experts think this is a good thing. They see it as a chance to rethink and maybe understand the universe a whole lot better. As Riess said, these aren't problems to be scared of, but chances to learn something new. But the surprises didn't stop with galaxies. The JWST also made the Hubble tension even more urgent, and that's one of the biggest unsolved problems in cosmology. For years, scientists have measured how fast the universe is getting bigger in two different ways. Measurements using exploding stars and special stars called Cepheid variables say it's expanding at about 73 kilometers per second per megaparsec. But calculations based on the afterglow of the Big Bang say it's slower, around 67. That small difference is a big deal in cosmology. The JWST was supposed to solve the problem by making these measurements more accurate, but instead it confirmed the faster rate. By seeing individual Cepheid stars in galaxies that Hubble couldn't see clearly, the JWST showed that the measurements weren't wrong and that the tension is a real issue. Riess said that this result makes the mystery and says that we might need to add new physics to our models, like maybe a kind of dark energy that changes over time or unknown things that affect matter. Some scientists have even wondered if these findings could mean that there's a kind of energy we didn't know about that made the universe grow faster in the early days, or that gravity might act differently on large scales than we thought. These ideas are still being looked at, but they show how big the problems have become. Meanwhile, something else happened that changed how scientists looked at the JWST's findings. A team led by Stephen Finkelstein looked again at some of the huge galaxies the JWST had found and made a crazy discovery. A lot of these galaxies weren't as big as they seemed at first. The reason? Supermassive black holes. These black holes in the middle of young galaxies called quasars can give off so much energy that they make their galaxies look brighter and bigger in infrared pictures than they really are. Once the researchers took the light from these black holes into account, the mass of some early galaxies went down a lot, in some cases by half, which made them more like what the models predicted. But while this fixes part of the problem, it creates another one. These black holes are a puzzle themselves. How could black holes that weigh millions or billions of times more than our Sun form so quickly after the Big Bang? That question has opened up a whole field of research, even as it helps fix others. Even with these black hole changes, the JWST is still seeing more early galaxies than we thought it would. The rate at which galaxies formed in the early universe still seems to be faster than what our current models can explain. This has made scientists rethink other things, like how quickly stars could form in the early universe, how dark matter clumped together in those early years, or whether the first stars and black holes acted differently than we thought. Some researchers are even thinking about changing the nature of dark matter or gravity itself to explain what we're seeing. Even with all these weird things, no one is giving up on the Big Bang theory. What's happening is that we're making the models that describe what happened later better, like how galaxies formed, how matter acted, and how the universe expanded. Scientists are checking out a bunch of possible answers. These discoveries have not only surprised astronomers but have also shaken up the standard model of cosmology, the lambda cold dark matter, lambda CDM, model. This model says that things in space form slowly, starting with small clumps of stuff that gradually become galaxies over billions of years. But JWST's findings go against that, showing a young universe full of huge, complex galaxies. Alison Kirkpater, an astronomer at the University of Kansas, said it simply, everything is too big, too soon. This difference between what we thought and what we're seeing is so huge that it's keeping some scientists up at night, wondering if the whole foundation of their science is wrong. This isn't just a small mistake. These findings are pushing cosmologists into what many are calling a crisis. The data has been checked many times, it's real, and the instruments are working right. The Atlantic even said that JWST's early observations made researchers consider that their old models might not be right anymore. Some experts first thought there were problems with the instruments, but that wasn't it. Now, what's left is clear proof, a young universe that doesn't match what we thought we knew about how galaxies and space structures formed. Even more dramatic are the reactions from the scientists who helped create these models. Dr. John Matherer, a Nobel Prize-winning physicist who helped design JWST and measure the cosmic microwave background, the Big Bang's afterglow, has said he's surprised. He said the galaxies JWST is finding aren't what we thought they'd be, calling them unexpectedly big, bright, and common. Coming from someone who's a big part of both Big Bang research and JWST's design, that's a big deal. Adam Riess, another Nobel laureate, led a JWST project to figure out the Hubble tension, a difference in how fast we measure the universe expanding. But instead of fixing it, JWST made it worse. Its super-accurate data confirmed that the local expansion rate is faster, proving that previous measurements weren't wrong. Riess said that we might be facing the possibility that we don't understand the basic physics of the universe. He wondered if we really know what the universe is made of or how its rules work. Then there's Sir Roger Penrose, a Nobel Prize-winning mathematical physicist known for his work on black holes. He sees the JWST findings through his own theory, conformal cyclic cosmology, which says that our Big Bang was just one part of an endless cycle of universes. According to Penrose, the surprising age of these early galaxies could be leftovers from a previous universe. Even though his idea is unusual, it shows how much these results are making even the smartest people in the field rethink things. Even with the shock, many experts see this mess as a great chance. Instead of seeing it as a problem, they see it as a chance to rethink and maybe greatly grow our understanding of the universe. As Riess said, these aren't problems to be afraid of but chances to make new discoveries. Yet, the surprises didn't stop with galaxies. JWST also made the Hubble tension, one of the main unsolved problems in cosmology, even more urgent. For years, scientists have measured how fast the universe is expanding in two different ways. Measurements using nearby supernova and Cepheid variable stars suggest that rate is about 73 kilometers per second per megapark. But calculations based on the cosmic microwave background give a slower rate, around 67. That 9% difference might seem small, but it's way bigger than the acceptable error in cosmology. JWST was supposed to settle this, but instead, it confirmed the faster expansion rate even more clearly. By seeing individual Cepheid stars and galaxies that Hubble couldn't see well, JWST ruled out instrument errors and made the tension a real problem. Riess said plainly that this makes the mystery bigger and suggests we might need to add new physics to our models, maybe a type of dark energy that changes over time or unknown things interacting with matter. Some researchers have guessed that these findings might even point to a type of energy we didn't know about before that sped up the universe's early growth, or that gravity might act differently on a large scale than we think. These ideas, while still being studied, show how big these problems have become. Meanwhile, another piece of the puzzle came out that changed how scientists understood JWST's findings. A research team led by Stephen Finkelstein looked again at some of the huge galaxies JWST found and made a surprising discovery. Many of these galaxies weren't as big as they seemed at first, because of supermassive black holes. These active black holes in the centers of young galaxies, called quasars, can send out so much energy that they make their galaxies look much brighter and bigger in infrared images than they really are. After the researchers accounted for the light from these black holes, the guess size of some early galaxies dropped a lot, in some cases by half, bringing them closer to what the models predicted. But while this fixes part of the problem, it brings up another one. The black holes themselves are a mystery. How could black holes so huge, weighing millions or even billions of times more than our Sun, form so soon after the Big Bang? That question has opened a new area of research, even as it helps narrow others. Even with these black hole changes, JWST is still seeing more early galaxies than we expected. The rate at which galaxies formed in the early universe still seems faster than what our current models can explain. This has made scientists rethink other ideas, like how quickly stars could form in the early universe, how dark matter clumped together back then, or whether the first stars and black holes acted differently than we thought. Some researchers are even thinking about changing what we think dark matter or gravity is to explain what they're seeing. Even with the growing list of weird things, no one is giving up on the Big Bang Theory. Instead, they're making the models better to describe what happened after, how galaxies formed, how matter acted, and how the universe's expansion changed. Scientists are checking out a bunch of possible solutions.